All right, welcome back to Lag Demon Programming and the compiler design course. In our last video, we did a little reorganization of how the program is set up. And in this video, what we're going to do is start working a little bit on a new module for this. And it's going to be the compiler that lets us actually create a dungeon. So the reason I'm moving from doing the command line compiler to doing this compiler is we need to have a dungeon to act upon with commands. We need to have something that commands can do. So we need to build a dungeon. We need to construct what that dungeon is going to look like and start building up the game that way. So to do that, before we do that, there's one little piece that I want to pull out, and I want to go in here, excuse me, and create a new folder, and I'm just going to call this include. And in here, we're going to first add a header file, new file. We're just going to call this. We'll call this one Lex Utilities, excuse me, Lex underscore .h. And we're going to move this, first of all, we're going to move this ast.h into this include directory. And we're also going to go in here to the Lexer and this template, parse number template that we created, template function that we created. I'm going to take this out of there and I'm going to put it in this Lex Utilities, and we're going to do our thing here. So pound if not def underscore Lex Utilities And if you're not familiar with this, what this does is it prevents multiple inclusions. I realize that there is a pragma once directive. It is not entirely standard in all compilers, so I'm old and kind of old-fashioned, and this is the way I've done it for a very long time, and I'll continue doing it. I'm not real fond of the pragma once directive, and we'll, you know what? I killed my buffer with that. So we'll go over here to Lex Utilities. We'll put this template in here, parse number. We'll go back to lexer.l and we will just include that. And the way we need to include it is we need to include two things here, I think. No, we don't. Pound include, hashtag include, it's going to be ..slant include slant Lex underscore utilities.h. And let's make sure it still compiles. Oh, we got the AST over there. And I should change the name of that file too. But over here in parser.y, we need to put in this slant ast.h. Let's make sure this compiles. It does not. Oh, SS was not declared in the scope. That's probably here. So we need to do I'm going to pull this over to the edge for one thing. SSTREAM dot, oh, S stream, that's it. We'll make, why isn't it like that? I can't type tonight. There we go. Still doesn't like SS. What doesn't it? Am I looking at the right place? Yeah. Oh, this needs to be standard string stream. Let me get back to include command line dot slant command line dot h in main. So this is now include instead of command line, which makes a little bit more sense. We don't want all of these things. Okay, there we go. So we'll have our header files, our general header files that multiple things need to access in this include folder, and everything compiles now, so we can test it, make sure game, and yeah, it runs. So there, we got that squared away. Now, so I call this game. So up here on this, at the root of this, I'm going to create a new folder, and I'm just going to call this dungeon. So this is the this is where all the files for the dungeon language are going to be. And so what we need in there is yep, what we need in here is a lexer.l file, new file. And in fact, we can call this something else. It doesn't have to be that. We can call this dungeon lexer.l, and we will need a new file, dungeon parser.y, and we need a cmake files.text. And in the cmake files.text, we need to add in the bison stuff specific so that it gets it specifically for this folder. And I'm just going to copy paste this in here. I wonder why this is not syntax highlighting for this cmake. Oh, it's not cmake files. Let me delete that. I'm sorry. Dungeon, new file, cmake lists dot text, and then we'll paste this in there. Now it's syntax highlighting. Okay. But do we want to call this dungeon? Yeah, that's fine. Dungeon parser, dungeon lexer, I got all that right. So this is the same kind of setup that we did before. Lexer.l. Now lexer.l is very similar to the other one, but we added some things in, and I need to explain those. So we don't need that, but we do need, so we got some other functions I really want to move into another module, but I'm going to leave them in here for now. So let's get started on this. We're going to need some of the same basic stuff. So if you remember, a lexer file, %% and %%. These are our three sections, right? And we have a code. We can place a code section up here at the top by going %, open curly brace, and then it's %, close curly brace. So the % goes before the curly brace. And so this is a section where we can place code. And we're going to place a variety of code in here, but we need some of the basic stuff. Oh, this is command line. I'm sorry. There we go. We need to do the naming stuff that I talked about before, so we need to put those options in here, and they go in this second or middle section right below this. So that's just putting the prefix. In this case, dungeon will be the prefix on it. So just getting this boilerplate in place, and then we need and in the code section up here, we need this extern int Dungeon Lex. And I think that's it for the moment. So, in terms of copying and boilerplate, so we're going to have some of the same kinds of functions, and I'll explain what these are. I'm going to put these in. So these are these defines, defining what a float is, an int, an identifier, very similar to what we did before, but I've got the word description, and end of line, and all in here. And end of line has a purpose in this. So we have our white space ignore that we need, and we could do this. We could do this other ways. So this is our first like capture, and that capture just does nothing. So we'll just put a semicolon. All right. Now, some of the things we want to tie. So we did simple things before. We captured floats, we captured ints, and all that. But what about things like a string? A string can be a bunch of characters between quotes, but it can also have some special symbols that we're all probably kind of familiar with. And those special symbols are things like when we do this, when we do like a printf, right? And we go, something, 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 some words or whatever, and we put slant n. Oops. We put backslant n. So that backslant n means put a new line in this string. So we need to be able to parse that and actually produce that string with those slant ns. And they're actually, to be really thorough about it, there's a bunch of slants. So how do we do that? Well, Lex supports this concept of being in particular states. And we can create those states ourselves. We can create states for this to be in. And the way you create a state that you want something to be in is like this. You go %x, and we give it a name. And we'll call it string start. Okay. So how is the lexical analyzer going to recognize a string? Well, if it finds a quote, and we have to use the backslant here for the pattern, because a quote is for a string, but we want the character quote. So when the scanner reaches a character quote, we've got an action that we're going to do, and we're going to use a macro that's built into this system called begin, and we're going to put the name of the state, string start. But then there's some things that we need to do in order to process these, and we're going to create some functions to do that. But I want to show you what the pattern looks like first. Okay, so if we do begin string start, what happens is the Lexer goes into a state where it will only recognize or look at patterns that begin with string start in these angle brackets. And so if we then put a pattern in here, for instance, we can use a negative pattern here. It's not a slant quote or slant n star. Oops, star's in the wrong place. Star, like that. What this is going to do is capture, this particular pattern will capture a whole bunch of text that is not a new line character, a quote, or a backslant. It's not any of those things. That's what this character means here. Not any of these items in this list. And we want to then do something. We want to take action here. So we're going to have a way of capturing that. And I'm going to show you, oops. And I'm going to show you right now how we're going to capture that. We're going to create some functions. All right. So the first thing we need to do is include we need to include vector up here. So this is up in our code section now. We'll go pound include vector. We'll probably have to include some other things, and we're going to create a static. Well, yeah, we could make this static. So we're going to create a static that this is only static in this context means that it's only accessible within this compilation unit. Nothing else, nothing outside of it can access it. And we're going to call this the string buffer. Except it's going to be a standard vector of character. All right. So it's not a string. It's a vector that contains individual characters. And we're going to have some functions to handle this. So for one thing, we want to be able to turn that vector or whatever vector that we pass it in. We're just going to use this one for now. So we need string as well. Need to include string because we're going to return a standard string here, and we're going to call this, and we're going to make this static as well. We're going to call this get string, and we're going to pass it a constant standard vector char and call it the buffer. All right. And I'll explain how, and you'll see very shortly how we're going to use these various functions. We need to include stream, which is contains our string stream function. So what we're going to do to get this string is we're going to go standard string stream ss. Then we're going to go for auto ch in buff. So this is just an iterator. We've seen this before, but we're just iterating across that buffer that contains individual characters. And we're going to go ss from ch. And then we're going to return ss.string. And this function will take that vector and turn it into a string and return it. We want to be able to easily clear this buffer. So we're going to go void, we're going to go static void clear buffer. And again, we're going to take a standard vector char ampersand buff. And all we're going to do is call buff.clear. Not clean, clear. And then the last two that we want is static void append character standard vector character ampersand buff char ch. And what this is going to do is take buff dot pushback ch. And we can do this directly on the buffer down there, but I prefer to do it with functions. We can then use different buffers for different purposes, for different things, and we can use these same functions and pass different buffers into them. That's why, even though I have one defined right now, I could have several, and I want these functions to handle several different buffers, and I don't want to get confused down there as to what I'm doing with each one. So, and then finally, we want to be able to append a string. So standard, static void append string standard vector char ampersand buff comma character pointer string, and then we can go standard string as str and for auto for auto sorry, I was looking at something and then I started to mumble a little bit. As string, we're going to go append character buff comma ch. So we're just going to reuse that function instead of rewriting it. Though it wouldn't make any difference, we could just do pushback, but we'll call the function. Well, let's just do that. Let's just go buff dot pushback ch instead of calling the other function. Okay, so there's the functions that we need. And so when we get this pattern, and it only will recognize this pattern when we're in the string start state, which is up here. So we've got this string start state. When we get a quote, the first time we see a double quote, we begin string start, which puts us in that state. At this point, it's only going to look at the string start patterns, the patterns that begin with this. It's the only thing it's going to look at. When it gets this, matches this pattern, what we're going to do is append string buffer, comma, and this is dng dng text. Should be dng text. What did we miss? That's the equivalent of YY text, right? Because we did this prefix. Okay. Well, sometimes it doesn't work out so easily with the command with the completion that's in here. So we have other patterns now, and what I'm going to do is copy these in and explain them to you rather than sit and type them all out one after another, because it's very repetitive, and I'll explain what all this does. So here is the rest of our string capture code for this. That's got to be there. All right. So what this, let me fix this. Okay. So as long as we're in this string start state, we've got a quote, we've gotten into the string start state. This one will capture any normal characters it finds. These will capture any characters that begin with a backslant. So backslant A, B, E, F, N, R, V, and T are all special characters that can be switched with a backslant, and they produce that character, slant A, slant B. So we're using the C++ compiler's knowledge of what a slant A is, and a slant N, and a slant R, and a slant V, and a slant T, and so forth, to actually put the real character into our string buffer with append character. And so that the C++ compiler is going to interpret this in the single quotes as a literal slant A character, or in the case of slant N, we know that means, you know, new line, carriage return, or whatever. This gets literally put into the buffer when our pattern matches the text, a slant followed by an N within quotes. When we get down here, here's the slant quote. If we're in the string start state and we get a quote, a literal quote, what we do is we duplicate the value of our string buffer. We do a get string and string dupe it over and we're getting its C string value out of that string. String's just easier to deal with up there. And duping it into the string value that's going to be in our parser. And we're going to take a look at that in just a second. And then this is just a debug statement, and I don't have that debug thing in there, so let me take that out. We can also put this down a line, make it a little easier to read. After we grab this with the except it's not DNG get string, it's just get string, and it's not DNG string buffer. It's not DNG. Oh, you got to take all this stuff off because I made them static. That's what you get for changing your plan for how you had stuff prepared. Okay, so it's append character, append string. That's a little easier to read too. There's DNG text. That's fine. So it's going to get that string buffer that we've been appending stuff to. It's going to do the get string on it. We're doing getting the C string from it and doing a string dupe into DNG val. Now we have to, at the very least, set up a minimal parser file so that we can parse this stuff. So here's our which one is this? Oh, I'm going to close some of these things. This is what I'm going to close that. I'm going to close that. Let me close all these. Dungeon, here's our lexer. Here's our empty parser. And here's our dungeon parser. So, at the very least, there's a few things that we need in here. So I'm going to copy the stuff at the top. We've already seen this and pretty much know what it does. Well, maybe I'll grab my whole example parser file that I wrote. I might have to edit it a little bit if I change the names of some things. And I'll start explaining it. So we've already seen a lot of these things. I have not brought in some of those functions because we're not working with a buffer. In this case, we're going to work with a file. But basically here I've set up some tokens. This is our string value from our union that we used over here. This is that DNG val str. That's this right here. We've got tokens set up. We went through all this. And I set up a very basic idea of what a room is. But we're not producing all these tokens yet. But that's okay. I believe that this should now at least compile. Let's find out. We probably have some errors. Really? Oh, I never added dungeon into the top level thing here. Command line. We need to add this subdirectory dungeon. And now we can try and make dungeon make list.txt library dungeon parser, dungeon scanner, dungeon parser .l or .y, dungeon lexer .l. What doesn't it like? Add subdirectory given dungeon, which is not an existing directory. Somehow dungeon ended up underneath game. I don't know how. Now dungeon's at the right level. Make ast.h. Could not find source file ast.h. think we want these in there right now. What's it not finding? Dungeon.h. Cannot find source file. Dungeon.h. Parser.y. This is the one. Don't want that right now. We haven't created that yet. Cannot find source file ast.h. What's it looking for? Here. It's not in here. Game. Dungeon. It's not in here. Dungeon parser.hpp. CMake error command line. CMake command line. CMake list.text9. Oh. This has to be include. Darn it. Typing too fast. Alright, well, at least it did the CMake thing now. We got out of that and we got a whole bunch of errors, so I probably did something wrong here. Append here declared void static. Append care. Oh, a typo here. Standard, not string. Standard vector. All right. Let's see if we got rid of a few. Prefix was not declared in this scope. Percent option. Prefix. All right. Percent option prefix equals DNG. Oh, sorry. I got these in the wrong place. They go up here with the definitions right. Best to put them right under the code. Alright, it's easy to do. You just got to look for things. String start was not declared in this scope. Percent. And yeah, okay, this also doesn't go here. Okay, it's easy to get this confused. It's above that. This has to be in this section, but not in the code section. It has to be out of the code section. So, DNG val, L val was not declared in the scope. DNG L val was not declared in this scope. DNG L val is defined parser. Is that the wrong parser? parser. It's command line. Did I do it wrong here in Dungeon Parser? DNG in, DNG. Okay, well, one of the things we definitely need is because I'm using string dupe, we need this. Let's take care of that one. String dupe. Is it in string or string dot? We've got string. Oh, that's in parser. Oh, that's right. We need string.h. Actually, let me grab all these. Let me just grab all these header files. And I forgot to put the parser in. That's why. Okay. I forgot to put the parser's header file in, which is why I couldn't find the other one. Let's see what it does now. And it worked. Okay. That was just a matter of header files. Okay. So we got to have string.h is for it's old style C stuff, string dupe. To be perfectly honest, I couldn't figure out how to do this any other way to get it over here properly and not have it stepped on by other stuff. So this little bit of code here should now process strings. So I'll go over it again real quick. We create a state with this %x directive here. That creates a state. We can create other states, and we will. We'll do some for comments and stuff like that. When the Lexer gets this token, a quote, a double quote, it calls this macro begin with string start being the state. And then from there on out, it can only run patterns in this. It won't even see this up here. This is non-existent to it. Only these function when it's in that string start state. So it matches these patterns and it calls these commands. When it gets the final quote while it's in the string start state, it gets another quote. That causes it to gather the string, put it in that union over there in the parser, and then call begin 0. Begin 0 kicks you back to the top level state. You're done, and it's parsing normally. And when it's parsing normally, it won't recognize any of these at all. It won't even look at them when it's in its normal lexing mode in the state 0. It won't see these. It'll have to wait until it sees another quote and get that. So that took a little bit to get started, but at least it compiles. We might even be able to run it, but we would have to modify the main function a little bit. Real quick, let me check here. So we're at 39 minutes. So I think we'll wait for the next video for that. At least we got it compiling. So it's building this. It's building our parser. Then I'll go over this. I started setting up the bits of the language that I want to do in here, and I've got our expressions in here as well. You've seen a lot of this, but I'll go over this in the next video. So thanks for watching. I hope you liked it. If you really liked it, hit that like button, and if you want to subscribe, please do. Always happy to see new subscribers. And I will see you in the next video. Thanks for watching.